Alright, what's up? We're back in business. Live streaming again. Some Lisp stuff. And we'll be playing some music along the way. Again from Ryan Cooper. I found this little playlist he made called Good Enough. I think that should be good enough. We'll see. And so yeah, we're playing around with this book. Hopefully trying to finish it as soon as possible so I can give it back to my friend who borrowed it to me. It's The Land of Lisp by Conrad Barsky, MD. Alrighty. So yeah, this is their website, landoflisp.com, if you want to check that out. They've got a sample chapter, chapter 8, I think. You can grab that there. And for those who haven't been watching, I am basically going through the chapters. First chapter was kind of nothing, so I skipped that. After, basically got Lisp installed, tried out Sublime Text, that didn't work, and now I am in Emacs, which is what most Lisp people would say you should be using. All the Lispers out there. And so in Emacs, if you're using Slime, you get this kind of an interactive buffer. So instead of having to go either run a whole file or run line by line and say a REPL, a normal REPL, this will let you. Let me turn down this music for my headphones, sorry. This will let you run right from the editor here. I can use meta control X, and it basically just runs the outermost form here. It just finds the outermost brackets, parentheses, and runs that whole chunk of code for me. So you can see when I run this, it just returns the name of the function that we created using defun, the defun function. It's a lot of fun. So yeah, that's what we're going to be doing, is going through these notes I typed out from the book, instead of trying to switch back and forth from the book, which is hell. It doesn't work. I went through it last night, or this morning, early this morning, kind of wrote out the important parts and put some comments next to each one so we can run through all these and learn the syntax of Lisp code, or what I call the basics, Lisp basics. So the next chapter, chapter 4, looks like it's going to have similar stuff, a little bit more advanced, just exploring more Lisp syntax. I don't know if that will have a game again yet. I thought this was a game per chapter, but it's good to learn Lisp anyway, any way that we can, I suppose. So yeah, after running this here and having square defined as a function now, I could technically run that here. Square and pass in a number like 42, and that will just take 42 and multiply it by itself. Right? 1764. Okay, once again, I forgot to switch to the big camera. There you go. Alright, so yeah, here we go. Here's define square. You can run that. You can see down here I've got the keyboard shortcuts that I'm hitting popping up. Hopefully you can read those okay. Because in Emacs we're using a lot of crazy key bindings. I'm having to learn this as we go myself. I'm not really huge into Emacs. I've dabbled in it a couple times, so that helps me get up to speed a little quicker, but if you're wondering what I'm pressing to do certain things, like as you can see right now, I'm just randomly hitting up and down. When I hit meta, which is set to my option key on my keyboard right now for Emacs, you can, I think, change that, but meta control X will run that code. And so if I were to try, say, square 2, 42, that's not going to work because we have not defined that, and it's not a built-in function. So we get that symbols function definition is void. So that should make sense. I mean, we've got, in Lisp it's a list, apparently, right? This is just a list, and this is a special kind of list where if you evaluate this, it has 3 parts, and those the last two end up getting passed to the first one, which is the function. So those get passed as attributes to that function, or to as parameters, perhaps. So you can see here in this, we define a function. This would be kind of like maybe in Python if we said n return n times n, right, with a tab there, which I'm not getting because I need to turn that off. I thought I turned that off. Maybe I'm not sure how Emacs works like that, but anyway, this is the same thing. Lisp works a little different because you just throw everything inside of a list, and you have to have 3 well, I shouldn't say that. You don't have to have 3 exactly. I'm not sure how this works. But let's move on to some of this other stuff here. So symbols, right? Symbols are apparently fundamental and are a data type and are case insensitive. So these two things here are not different. They both say foo at the end of the day. Like if you lowercased both of them, they would just be this, right? And this is, I assume, an equality function. Let's run that, and we'll see it'll probably return true. Nil? That's not what I'm expecting. Should be returning true, I assume. EQ 2 and 2. Yeah, that's true. Why is that not true? That won't work without those, I don't think. Well, I don't know why I'm getting nil on that, but nil shouldn't be the same as true, I don't believe. Oh, we'll have to find that out. Anyway, so we've got floating point and integer support here. We can do 2 plus 1.0 and that'll give us back a decimal 3.0. Obviously, if we did 2 plus 1, it will just probably return an integer. Makes sense. Okay, so in the book they were kind of trying to explain that Lisp can do some fancy math stuff better than some other languages. For example, getting the exponent of a number not really exactly a small, not a tiny number here. It would take in most programming languages a few extra steps than might be necessary. In Lisp, it seems to handle this pretty well. It goes pretty quick. What did they do? 53 in the book. And I think I'm getting some weird output here because I'm in the slime. I'm getting slime output here. Let's take this real quick and do SBCL. So that should give me a common Lisp REPL here. And so you can see the full output a little better here. I think we're getting some fancy translations in the slime output. But yeah, this is basically, this is giving you that larger exponent without doing some extra processes that aren't necessary. I don't know the best way to explain that, but as you can see, it does run pretty quick. Pretty cool, I guess. Let's abort this guy. And we'll go back to our slime interactive editor. Alright, so this is where I got really thrown off the other day. Seeing, let's see, X. This should give me 1/2, right? It's not doing the same thing as before. Which numbers did they have? I think is it 2 and 4? Should be the same. Why am I getting a 0? That makes sense, but why does that not give me... So the crazy thing is, Lisp actually will return a rational number instead of a decimal in cases like this. Not sure why it's not doing that here now. It was doing it earlier. Actually, it was giving me both. Let's jump back into SBCL real quick so I can show you this. 2, 4 should give 1/2. Yeah. So you'd expect to get, if I divide 2 by 4, I should get 0.5. 0.5 decimal. I don't know, or if it's not handling decimals right, maybe you'd say 0 or 1. But yeah, this is pretty wicked. But if we do a decimal in there, same number basically, 2.0 by 4, we get a decimal representation. So, okay, interesting. Let me refresh this stupid chat thing that doesn't work. Alright, so next we have strings, right? Double quotes. The book doesn't say anything about single quotes. Oh yeah, I doubt we can use that because that's not gonna work. That's gonna turn that into a symbol, and then it's like, that's not a symbol, what's that? So yeah, double quotes. All strings are double quotes. Imagine interpolation is something we'll have to look and see if that's an option or not. I'm gonna guess not. But anyway, you can see I'm running prints around this because if I send this to the REPL invalid function skulls, yeah, it's trying to evaluate this as a form, I want to say. and it is basically just a piece of data. So you can see here, like, we can choose to run things as data by putting, or we can convert it to data by putting a single quote in front of it. But in the eval here, that still kind of freaks it out. So that's why I had prints on it, to just print out the string. This will just print out the code, which is a list with one item in it. And because we're running it through eval or through slime, you can see it's showing up twice down here. Right, same down here. We're getting the output from the print statement, and then the REPL is automatically just returning whatever the result of running that was, which was printing it out. So that's just a characteristic of the REPL. If I were to do, say, send this data, which is a list with just one string, then our interpreter here is actually returning that string, that data to us. This REPL actually just kind of returns everything to us, as opposed to actually trying to eval everything that we send to it. At least that's my understanding of it. One. And yeah, I'll keep this open for now. So yeah, you can throw double quotes inside of the string by using the what's that, backslash escape sequence, I suppose. So you can see I've got a couple of quotes inside of that, so that doesn't end our string, because we escaped it using the escape sequence. Okay, so apparently something important to understand that I'm still trying to wrap my head around is that data and code are kind of the same thing, right? So anything that I have that's this is a function, right, that I'm passing something to, and I'm expecting to evaluate it that way here. But if I put a single quote in front of it now, this is represented as data. I mean, at the end of the day, it seems like everything is code and data. There's no difference between the two, the way that Lisp defines how you have to interpret things. So if that makes any sense, as I was kind of talking about, in the Lisp REPL, the compiler assumes you want to execute everything, and Lisp is always looking for lists. So even your code, your code is like data, is a list, always a list, right? And executable code should be a special type of list, which is called a form. A form is a list starting with, where are we? Starting with a command at the beginning. So here we have an empty list. Here we have a list with 2 items. But if we, like down here, we have a list that has a function name at the beginning of it, and so it is therefore a form, and then everything else that's in the list gets sent to that function. So they can be optional, right? So exponent requires that you send 2 things to it. If I were to take one of those out, it'll say wrong number of arguments for that expt function. I gave it 1. It doesn't tell me how many it wants, I guess, but it does need 2. So that's just getting the exponent for 4, 2 with a length of 2. And to demonstrate the idea of everything really is a list, I mean, you can get the or also to demonstrate nesting here. So you can see I can pass, one of the arguments can be an actual list. This list will return an integer, which is what, or some kind of a number, which this function is going to expect. So both of these are essentially equivalent because this form here evaluates to 2, and when this gets called, this is going to already be evaluated. So they're not talking about it at this point, or at least I haven't seen this in the book yet, but in Lisp everything is going to be evaluated from the inside out, right? So it's going to start with the most deep list that it can find, evaluate that, and then keep traversing up of that tree. So in data mode, everything is assumed to be data. So the same form that we had above, we put that single quote in front of it, and now it is just data. We don't see anything in this slime output because it's basically just returning the last thing, I think the last executed result, which, or maybe it's actually going up. No, that doesn't make sense. I'm not sure why we're seeing chicken.cat at this point. Either slime is broken or my install is broken, but we can jump back to this SPCL REPL real quick. And we'll try this out, right? So we have exponent of 4, 2, 16. Let's do let's send this data exponent, which is a list, happens to have the name of a function and 2 numbers after it, and that's what we get back. So this is data. This is Lisp data, but we can see here it's just Lisp code. So I could probably say eval. I wonder if eval is a function. xpt 4.2. Yeah. So it just evaled that data, took that data and said, okay, your code, let me try to run you as code. If that makes sense, I think. That makes sense to me. It's a little bit loopy, but it's one of the, I think the benefit of Lisp is thinking about things as kind of like loops, right? Where everything is just a nested chain, or tree, if you will, of nested chains, which seems to be, I don't know, it seems to conform to nature to me. Some other stuff I was reading recently about this was talking about how in Lisp there's actually only atoms and cells. And so an atom is like a symbol, right? And these can be, like we were talking about up here, they're not case sensitive, right? So they're case insensitive. And I know that we can have, I think, letters and numbers and dashes and some other symbols too. What's up, Jethro? Thanks for stopping in, man. I hope it's entertaining enough and you do learn something at the same time. I'm learning, so at least it's helping me out, and if anybody else is trying to check out Lisp, then this might be a good way if you're at the beginning, and hopefully know a few other languages or something like that. But I mean, heck, if you can start using Lisp as your first scripting language or first language at all, it might help you to learn other languages better. So yeah, Lisp is a computer programming language. Technically, Lisp is actually a specification that tells people how to create programming languages that adhere to that standard. So you've got Common Lisp, you've got Clojure is a Lisp language, and there's a whole bunch more, probably 100 or more. So yeah, so we're just talking about how it's, the beauty of Lisp, if you want to call it that, is that it's tries to do rearrange all your code and all your data into the most small type of organizational unit, and so everything then is compatible with each other in a way, or it just seems more natural, I guess. But we won't really get into that because it's just pontificating on whatever. I mean, what I like doing is just being able to use a language. I've done this with Python and Ruby on Rails, or Ruby, PHP, and JavaScript and whatnot. And Lisp has always been one of those where everyone says, you got to be a super genius to understand it, and it's, it'll change the way that you think. That's all well and good, I guess. I don't know. I don't agree necessarily that you have to be a genius to know it. Just like solving a Rubik's Cube. There's directions online. Just follow the directions, and eventually, if you keep doing it over and over again, you can start to see the patterns in it. And that's the way I approach it myself. But yeah, so going down here, so we've got this nested list, and we have a form which is a function call. We can see how this is the same thing, but it's represented now as code because it's got this single quote in front of it. And you can see how like these two guys are really the same thing. This one with the second list in it that has two, that has another list inside of that for the second one part of it, right? So it's like 1, 2, 3, close the 2, close the 1. So that's interesting way to do the same thing, which is this, right? And we basically get that because everything in Lisp, like every list that you deal with, is using this concept called cons cells, right? So that's where we get into the idea of a cell, I suppose, is that you've got, like, any list is represented as, like, if I have 1, 2, 3, really what's happening inside of Lisp is it's looking at it as if it were 1, 2, 3 inside of nested lists. So everything is always going to be represented that way to Lisp. And what it is going to do is say, okay, let me look at this first list and evaluate it. Oh, well, it's just a 3, so here's, there's what you get back. Same thing with 2. 2 is just a list with itself, and then a list containing 3. So really that evaluates to 2, 3. And then the first one is 1 with a list of 2, 3. And that 2, 3, since it evaluates to 2 and 3, it's the same thing. I mean, this is like getting into the nitty-gritty. You don't have to necessarily understand this stuff to use Lisp, but this is the basics that if you don't understand it, some things are going to look a little bit weird to you, perhaps. And so the way this actually happens, and the way we can use it in our code too, is using the cons function, right? So this function will, yeah, so Jethro, it's like a link, right? It's just referencing it as a linking to the same exact thing. Like, so if I had 1, 2, 3 here in the same piece of code, Lisp is going to see that those two things are identical, right? And so they're represented as one element on the machine end of things, right? So on the actual hardware register, to my knowledge, I believe that those two things will end up just being references to the same place in the processor or in memory. So let's actually see this happen in action, right? So we've got, if we cons two things together, right? That's what we call as consing. We cons the symbol chicken and the symbol cat. What we got back here was chicken dot cat, right? So the dot is not actually like this isn't a list with 3 elements. This is I don't know what to call this, a cons list. And it's showing that chicken is now linked to cat. So if I understand that correctly, it's kind of like basically we had chicken and cat. So we'll do a little bit more of this here. So let's cons chicken and nil, right? And so instead of getting chicken and then nil, nil is like nothing, really. In Lisp, it's the way of really denoting nothingness, which is identical to an empty list. So if we do this const chicken in an empty list, we get the same thing. We just get chicken back because you don't const to nothing, and you don't really like evaluate nothing. Nil is actually how Lisp denotes the end of your list, right? So technically, Lisp is always looking for the first of all the inner list, right, and then really the innermost list. And at the end of the day, it needs to know where to stop, and so nil is actually something used to stop or terminate a list, right? So terminate meaning like, okay, hey, I need to let anybody looking at this know this is the end, you don't have to look further anymore. So deep in Lisp, you don't have to do this yourself, you don't have to end all of your lists with nil, but if you look at how Lisp is being interpreted, that's the way that it's taking all of what you typed and organizing it in a way that the interpreter can understand it, right? So let's see. Yeah, so I just typed that. I don't need that. Yeah, so here we're cons. We're gonna rename this. We're not gonna do pork. We're gonna do avocado, and we're gonna put in tomato and chickpeas. Nah. How about lettuce? We'll go simple. Yeah, so let's execute this again. Command Control X in Emacs here. We const avocados what do you call it? Symbol, the symbol avocado, to a piece of code, tomato and lettuce, which is the code is just a list with two things in it, right? So what we end up getting back is the list avocado and tomato and lettuce, right? So this basically is equivalent. So by having run this, we have const, this is the terminology, we have const avocado to a list containing tomato and lettuce. You can see I'm going through and changing all of the meat references to vegan references. I'm not vegan, but I like to be all-inclusive too. So yeah, so Jethro in the comments is saying, so nil is like the end of a loop. And yeah, I mean, that's, at least to my understanding, the way that nil is working, or one way that nil is used in Lisp is to let the interpreter know when it can stop looking for a continuation of a list. Like even if we're not nesting anything, right? A list can contain as many things as you want, right? And so instead of the language really looking for, the language I don't think is really using these parentheses in the core of it. It's just seeing everything as a list. It's represented as kind of as like I don't know if you want to call it an array or list or whatever, but in Lisp it needs to know like what is the end of that. So like if we looked deep in the interpreter at how this is being 1, 2, 3 are looking in the code or in the machine language, it's or how the interpreter understands it at least. It's actually 1, 2, 3 and an empty list, or we can call that nil. If that, I think that kind of makes sense. Again, that's something that you'll kind of, I think, just has to sit in the back of your head so you understand how the language is working at the core. But what we really want to do is get to more of these functions, right? So cons can combine lists, that's great. I don't even know when I would use that or how I would use that, but we know that that's how things work, right? Everything is a list. Cons can combine elements, even other lists, right? So if I cons the symbol lettuce to a const symbol tomato to a const symbol tofu, again, that's the same thing. This is really kind of what's happening inside of Lisp. When I was talking about sending nil to the end, you can see here we are sending nil to cons. Cons takes 2 arguments. It has to. If you don't send 2 arguments to it, we'll end up with something like this last line here, cons lettuce, cons symbol lettuce to cons symbol tomato. Inside of this function right here, you might notice already that there's not a second element. So like if I did potato, or potatoes or whatever, that would make sense. I'm consing tomato into potato, but you can't cons tomato to like nothing. It either needs to be nil or it needs to be, or an empty list, I guess, or nil, which are the same thing. But you can't pass just one argument to it, or you'll get an error, right? And this is really diving deep into the core of Lisp, but it's worth understanding how cons works. I'm sure there's some interesting times where you would want to use that, and you'll have to just know that, let's say that you wanted to build some sort of a function that can combine things in some way. If you're going to use cons, which you likely would, in order to do that, then you'll have to, at the end of your chain, your loop chain, right, make sure that the last thing sent is an empty list or nil. Make sense? So there's a whole lot of different functions that do sit on top of cons. Some of these built-in ones are car and CDR. And so we can see what car does is gets the thing out of the first slot, right? So in a list, let's call these slots, and there's one slot or one item in the first slot. There's item in the second slot and an item in the third slot, right? Lettuce, tomato, tofu. Lettuce is in the first, tomatoes in the second, tofu is in the third. And if we call car, it will look at that data that we give it and return back just the item in that first slot. So we'll do that, we run it, and we get lettuce, because that's what is in that first slot. And CDR will give us the second, right? Yeah, the second item in the slot. So this is interesting. I think the reason we're seeing... Oh no, that's not right. Why? Hang on, I need to understand this. CDR, or is it the rest? I'm sorry, CDR is the rest. I think I typed this wrong. Cons, car, CDR. CDR is used to grab the item of the second slot or the remainder of a list. Yeah, so technically I guess the second slot is always the remainder. If you go back to what I was saying earlier about how everything is just a nested list, right? So technically everything just has a first thing and then maybe the rest of it, if there's something else in there. And the rest of it would be like if I had 3 items in a list, 1, 2, 3. Technically there's 1 and then there's this other list called 2, 3. And then technically inside of 2 there's 2 and then there's the third list, which is 3, and then the terminating nil. And nil has just the last item because that's the terminator. It's the terminator. So yeah, so CDR is going to give us the rest, and car is going to give us the first. And you can actually string these guys together, do car and then CDR. So okay, we're going to get the rest of this code, right? The rest of this list. So the rest of that would be tomato and tofu. The list tomato tofu, and car is going to take those now and say, okay, give me the first item in the list. So you can probably guess what that's going to be. Tomato. Oops, I keep double clicking that. Okay, so there's more you can do as well, like you can combine these into just one function and it will do both of those in sequence and give you the same result, tomato. Right, so basically CADR is just going to give you back the second item alone, no matter what the rest of this is. That should make sense. Okay, so sorry I missed your comment here. Jethro says, so it asks for 2 parameters at first. Um, yeah, so I think you're talking about like maybe cons, right? Cons takes 2 parameters. It's got to have 2 parameters. XPT, right? Exponent also has to have 2. If I did the same thing here, I did XPT1, it would say, what are you talking about, dude? Oops, I hit the wrong button. Same result, different button. Here you are. Run that guy. Yeah, wrong number of arguments expected. Or AXPT, you gave it 1. It actually takes 2. You have to give it 2. So in some, the cons function is the same. Not all functions are that way. There are functions that take, for example, there's the prints function, which just prints something out, and you can pass it just one argument. Let me move this chat up a little bit. Okay, so I got scroll hell over here. This goes way too fast. Let's remove this guy. And alright, so we're back to car. And we had car and CDR used together here. And then the one function CADR, which is the equivalent of CAR and CDR. So, and you can actually, thought that I mentioned this in the notes, I don't see it, but these you can chain together up to 4 levels deep, it said. Did I put that in here or not? Yeah, so here we go. So you can see like CADADR, right? That's going to take a piece of code, which is it's obviously where you have a list. The first item is a list of 3 items, the second item is a list of 3 items, and the last item is just sprouts. And CADADR, let's see, so what order is this going to go in? So I think we're getting the second item out, and then the second item out again, so I think we'll get beans. Yeah, there we go. So you can basically combine these in any way. All of those functions will be automatically, they're available to you up to 4 levels deep. So let's see, this was 2 levels deep, I want to say, or is that technically... Yeah, I think that's only 2 levels deep. 1, 2. So if beans was another list, beans and rice, and we can do, let's see, AD, I think CD, I think A will give us the first item of that. Nope. Oh, maybe that's the 4 levels deep I already did. Maybe that's what they meant by levels. 1, 2, 3, 4. That must be, yeah. X. Yep, that function just doesn't exist. So can I do like CD? What happens if I do C, D, D, D? There's nothing there, so I think that's, what is it looking for? I do not understand how that works. This is so weird. C, what was it, CADAD, right? So that gives us beans and rice, because that's the second item in the second. And it's car and CDR. So I'd expect, what if I do CDAR? Carrots and tomatoes. Okay, so I'm getting the rest of the first element. So I think this is happening reverse. So A gives me the first, and then D is giving me the second, or the rest of that one. So then if I did, I think CDDAR gives me tomatoes, because that's the rest of the first. Yeah, that makes sense. So we're just going reverse. Cedar. Cider? No. Okay, so let me actually put this back where it was. CADADR. Beans and rice. I'll put this back on beans. I'll be saving this file at some point. Or right now, I suppose. Chapter 2. Okay, so that's basically it for this chapter. I'm gonna start up another video for the next chapter soon. I don't know if that'll be tonight or when exactly, but just to recap, we learned that parentheses in Lisp are how it keeps syntax minimal, and everything is wrapped in these parentheses, and that's how we denote lists and list items within lists and nest things, kind of like you have in math syntax, right? Or is that algebraic syntax? I don't know. Lists are created from cons cells. So that's the 1, 2, 3, right? These are just the same thing as 1, 2, 3, or I should say this 1, 2, 3 is the same thing as this 1, 2, 3, which is what's really happening is cons of 1 and cons 2 and a cons 3 to nil, right? And a couple last things here that we learned was you create lists with cons cells using the cons commands. You can actually do that in your code. And you can inspect pieces of a list with car and CDR and the rest of those. So yeah, thanks Jethro for coming into the live chat. I hope to see you in the next one and on the rest of the videos that I make. If you got any feedback or suggestions, do let me know. I set up a Patreon account. If anybody wants to check that out, I am uploading photos and videos to there now, and I've got some rewards set up. And if you just want to send me money to buy me a beer, go to paypal.me/DavidLived. Alright. Thanks everybody.